Hi everyone. Okay, let's try another example. This is going the opposite direction, but I just really want to make sure that we're comfortable with how this notation works. Once you get the hang of it, it's not bad, but it is crazy looking, so it can really throw people off at first. So again, when you're looking at this, that squiggly bracket says we're going to use three separate equations to make a single function. So sometimes we'll use y equals x as our equation. Sometimes we'll use y equals 5 as our equation, and sometimes we'll use negative x plus 2 as our equation. And then over here, we're told when that sometimes is. So we're going to use y equals x, but only when the x's are less than negative 4. We're going to use y equals 5, but only when the x's are between negative 4 and 2. And we're going to use y equals negative x plus 2, but only when the x's are greater than or equal to 2. Okay, so to get started while you're learning this, you can just ignore the domain restriction and draw the entire equation. And then we'll just erase the pieces that we don't want. We'll see how that works on this electronic thing, but that's the idea. So piece number 1 is y equals x. And I know what that looks like. So here, I'm just going to draw it in dash line because otherwise when I erase, it'll take the whole thing. Y equals x. Okay, so y equals x has a slope of 1 and crosses through 0, 0. And that's the first part of my graph. So I visualize that, sketch it lightly if you need to. And then what you're going to do is apply a restriction to it. You're going to say, okay, but I'm only supposed to use that if x is less than negative 4. I should have made my grid a little bigger. So here, we'll continue down here. So we're going to go to where x is negative 4, which is actually this bottom corner. And we're going to put an open circle on the graph. And it's open because that's a strictly less than. There's no equal to. And then it says keep everything less than that, which is the same as saying to the left of that. So this is the first piece of my equation. If I gave you any grids too small, feel free to either scratch out the labels and relabel or just run off the edge a little bit, just like this. Okay, so this is piece number 1. Piece number 2, let's use blue. Okay, so piece number 2 is y equals 5. And y equals 5, yes, again, terrible, me with the not making a grid big enough. Y equals 5 is going to be up here, and that's a horizontal line. Okay, so I'm picturing that line, and I've just drawn it in lightly because I know that I'm probably not going to keep all of that. And then I move over and I say, well, when am I supposed to use that one? And the answer is you're supposed to use that one between x equals negative 4 and x equals 2. So I'm going to want to erase the stuff outside of there. And then I'm going to think carefully about open and closed circles. It says at negative 4, I should have a closed circle. And the way it says that is with that less than or equal to. So if there's an equal to, it's a closed circle. On the right, it's strictly less than 2. So I'm going to use an open circle on the right and then just fill this in more clearly so that it's obvious that that is part of what I'm keeping. Okay, so piece number 2 of my graph is we jump way up, and there sometimes the pieces will connect and sometimes they won't connect, and it's really fine either way. Okay, so piece number 3, and there's no reason you need to do these in different colors. This is all a single function. I'm just doing that so that you can see what comes from what information. Piece number 3 is y equals negative x plus 2. So that's aligned with a slope of negative 1 and a y-intercept at 0, 2. So it's going to go like this. And we're supposed to keep that if x is greater than or equal to 2. Okay, so 2 is right here. And these have all lined up really nicely on grid lines. If you're ever in doubt about what the y value should be, remember you can go and plug that 2 back into the appropriate equation and verify that it really should be right at 0. So at 2, 0, we have a point. And then we're supposed to keep x greater than or equal to that. So greater than is going to be to the right of that. So we want to keep all of this stuff, and we want to erase all of, if it'll erase for me. There we go. Oops, I took my circle. All of that. Okay, and then I want to be really clear that this entire thing made up of 3 completely separate pieces is function H. And one thing you can do to check yourself is if you've done this correctly, your graph really should be a function. So it should, blah, blah, blah. It should pass a vertical line test, which this does. There are questionable spots at 2 and at -4, but it works. There's an open circle and a closed circle, so it really is a function. The other thing I want to point out is that just imagine, so this is complete, this is the perfect graph for our h of x, but imagine when we had gone to graph the third piece that it actually hit this point right here. So let's say it goes out like that. If you ever put a closed circle on top of an open circle, it fills it in. You don't need a closed circle anymore. Fill it in. I'm sorry, you don't need an open circle anymore. Fill it in. So if a closed circle goes on top of an open circle, there is now a point there and it is just not open anymore. So open, closed, closed will win. Closed will fill in open circles. Okay, I want to do one last thing here. I want to show you in Desmos that you can actually do these domain restrictions, and you can even build up the piecewise. As far as I know, it doesn't have the notation to do the squiggly bracket, but you can kind of do it the T1, T2, T3 way. So this is just go to desmos.com and hit graphing calculator, and we're just going to go ahead and start typing in the pieces. So the first piece was y equals x. The second piece was y equals 5, and the third piece was y equals -x plus 2. Okay, and then I need to, looks like, zoom out a little bit here. So I'm just hitting control and then scrolling out on my mouse. You can also pinch if you're on a touch screen, or you can go to the plus minus to zoom in and out, or hit settings to type whatever you want in. You could type in the x values and the y values you want to see. Okay, so this is great, but it doesn't really give me the picture that I ended up with because it doesn't have the restrictions. So in Desmos, the way you do a restriction, sorry about that, is with squiggly brackets. So you're just going to put squiggly brackets at the end. You don't need parentheses around the first part, just the squiggly brackets at the end, and then type your domain restriction. So we wanted x strictly less than -4. And then we wanted -4 less than or equal to, and you really just do type less than and then equal to, and it'll turn it into that. The less than is on your comma button, and the greater than is on your period button. X less than 2. And then we want the -x plus 2 from for all x greater than or equal to 2. Okay, so now it's even restricted them for me. If you want, you can make them all the same color. I don't know if you spotted that. I hit the settings button up here, and then if you just click on this, so here I'm going to make them all blue. You can make them all blue. Another thing you could do is if you want the open closed circle, you certainly don't have to, you're hand drawing these generally for me, but let's see. We want an open circle at -4, -4. So you can put a point there, -4, -4, it'll put a point. And then when you go into settings, you can make that point blue. And up here, you can choose your marker. You can put an X or you can put an open dot on it. And you can even change the size of it if you want. Sometimes I don't like how little they are. That makes it bigger. At -4, 5, we wanted a closed circle. I'm just going to make it blue. I like that it's already closed. And you can change the size of that if you want as well. At 2, 0. Whoa, what did I type? There we go. We wanted, what did we want at 2, 0? A closed circle. And then, oh, I skipped one. At 2, 5, we wanted an open circle. Probably best to just type these all in and then do settings all at once, a little less tedious. Okay, so I'm not asking you to do these in Desmos, but for some of these problems, I think you might like to do at least the first part. You probably don't need to put all the open and closed circles in for yourself, but being able to add these restrictions and play around will be kind of nice in some of these problems where you're trying to figure out the equation yourself. So, okay, hopefully that helps. Thanks for watching.